Problems 9 and 10. The following information applies to questions 9 and 10. A 0.65 kg ball moving at 5 meters per second collide with a 0.75 kg ball that is originally at rest. After the collision, the 0.75 kg ball moves off with a speed of 4 meters per second, and the 0.65 kg ball moves off at a right angle to the final direction of motion of the 0.75 kg ball. Question 9. What is the final speed of the 0.65 kg ball? Solution. Here we can draw a diagram, and from this diagram that will be easy to find the answer for the question. In the case of this collision, we have momentum conservation. It means that initial momentum P of the first ball, it was split by P1 and P2 by right angle. So from here we can write equations. In vector form we have P equal P1 plus P2, but because this angle is right, we can write another equation. We have P square equal P1 square plus P2 square. And now we can insert momentums. We have this equation from which we can find what is the speed of the first ball v1 after collision, equal this expression, or after put numbers we have 192 meters per second, which is answer A. Question 10. Let the change in total kinetic energy in this collision be defined by delta K equal Kf minus Ki, where Kf is the total final kinetic energy and the Ki is the total initial kinetic energy. Which of the following is true? Solution. First of all, without calculations, we can tell that this collision is not absolutely elastic, because only in case of two equal masses we can have the angle between final momentums could be 90 degrees, but our balls have different masses, so it's not perfectly elastic collision. It means that the final kinetic energy less than initial kinetic energy, and we can tell that delta K must be negative and less than Ki in value. And from this point we can check our answers. So first answer, delta K equal this one, it's not correct, because delta K is negative and the right part is positive. Same thing with B. We have Kf is positive and delta K is negative. C is not correct because delta K is negative. D is not correct, delta K is negative. And E is correct because delta K is negative, and by value that's less than Ki. So E is correct answer. Problem number 11. A sphere floats in water with 2/3 of the volume of the sphere submerged. The sphere is removed and placed in oil that has 3/4 the density of water. If it floats in the oil, what fraction of the sphere would be submerged in the oil? Solution. Because 2/3 of sphere submerged in the water, we can write equation. volume of a sphere multiplied by rho sphere equal 2/3 volume of a sphere multiplied by rho water. From here we can find that rho sphere equal 2/3 rho water. And also we know that we have rho water equal 4/3 rho oil. If we put this to this one, we will get that rho sphere equal 8/9 rho oil. It means that 8/9 of sphere will be submerged in oil, which is answer C.